Okay, in this video, what I want to cover is I want to go over the solubility rules. So in general, recall what a salt is. A salt is any ionic compound which contains a cation and an anion. So in general, salts, they are prepared from an acid-base neutralization reaction to give salt and water. Those are the two products. And there are three kinds of salts. And that's what I want to define in this particular video. So the first one is those kind of salts which are always soluble. So these are the salts that are always soluble. So when would you see that? You would see a completely soluble salt if it is either a group 1 cation containing salt. That means if it contains, let's say, lithium, if it contains sodium, if it contains potassium, it contains rubidium or cesium. And in addition to that, ammonium, that has a tendency to behave pretty similar to the group 1 cation. So in general, if you see group 1 cation or ammonium, they will always remain soluble. As far as anions go, anions, if it is a nitrate, NO3 negative, if it is a bicarbonate, HCO3 negative, if it is a chlorate, ClO3 negative, if it is a perchlorate, ClO4 negative, and last but not the least, if it is an acetate. Those are sure shot, they will have to be completely soluble salts. The second category that I want to talk about is, in a sense, usually soluble, but with exceptions. Exceptions. And I want to put the exceptions in parentheses. So there are two kinds within this. One is halide. In general, we will use the word halides for chlorides, bromides, iodized. So all kind of chlorides, bromides, iodides are in general soluble, other than when they are halides of silver, if they are halides of mercury, or if they are halides of lead. The other category is sulfates, SO42 negative, so sulfates. And within this, the exceptions are again silver, mercury, lead. And in addition to that, I also have the three members from group 2, calcium, strontium, barium. FYI, barium sulfate is among the most insoluble materials known to mankind. The last category is the category of insolubles. So if I did not discuss that in the first category, let's just call that category A, or the second category, which is category B, that would be an insoluble. So let's say if it is an oxide, if it's a hydroxide, if it's a phosphate, PO4 3 negative, maybe it's a sulfide, maybe it's a chromate, maybe it's a carbonate, sulfite, etc. So if I didn't place it in A or B, you would think that that's an insoluble, so oxide, hydroxide, phosphate, but realize that if these are bonded to group 1 cations, then it is the rule for group 1 that is what you're going to follow, and in that case you would say that that particular salt is soluble. So what I mean by that is, if you have something like perhaps Na2CrO4, so that's sodium chromate. While you would imagine that chromate, CrO4 negative, that should place it in the insoluble section, but because it is a sodium salt, you're going to say that it is soluble. And whenever something is soluble, you're going to report that in the parentheses. You're going to write that as AQ in the balanced chemical equation. So in subsequent videos, you're going to see how we do that, how we write down the precipitation reaction, etc. And I'm going to give you more information on that way. Okay? All right.